This is a solution to problem number 5 from the Triangle Trig applications notes. This is another vector application which we're going to solve using triangle trigonometry rather than vectors. So we're told that an airplane is flying at an angle of 80 degrees north of east with a speed of 260 miles per hour while a 16 mile per hour wind is blowing from the west. And we're asked to find the plane's resultant velocity and direction. So I'm going to go ahead and make a sketch of this situation. So we know that an airplane is flying 80 degrees north of east. So north of east would be above the horizontal. So I'll just put the directions here. So north, south, east, west. So north of east at 80 degrees. And that its speed is 260. So I'll put that here, 260 miles per hour. And 80 degrees is like the angle of elevation for this problem. And then there is a wind blowing at 16 miles per hour from the west. So from the west actually means that it's blowing to the east. So then we have a 16 mile per hour wind. So this would be, if we were doing in vectors, this would be our W vector. And we're asked to find the plane's resultant velocity and direction. So I'm going to create a triangle. And this red line is really what I want to find. This is going to be our resultant velocity for the plane. Let's see. So now we need to set up our triangle. So we know that one angle is 80 degrees here. This is 80 degrees. But the 80 degrees is not in our triangle, right? We have this triangle here that we'd like to use. So I would like to figure out some angles within our triangle. So to do that, I'm going to go ahead and I'm going to drop in an altitude. So this is a right angle. And I'm going to focus on the little right triangle that we made so that we can figure out the angle within our triangle. So I'm going to redraw this small triangle where we have 80 degrees inside the triangle, a right angle, and that means that this angle up here at the top is going to be 10 degrees, right? Because it's 180 degrees minus 80 degrees minus 90 degrees. So that 10 degrees corresponds with this small angle right here. So this is 10 degrees. And then I also know that this is a right angle. So this is 90 degrees. So now the angle within the triangle that we want is going to actually be 100 degrees. So this angle here is 100 degrees. And I'm going to redraw the triangle now so that it's a little clearer what we're doing. So we've got the plane at 260 miles per hour, the wind, the resultant, and this side length is 260 miles per hour. This angle up at the top is 100 degrees. This side at the top is 16. And that's what we need to be focusing on now, which will be a lot easier to work with. And I highly recommend that if you need to redraw some of the triangles as you work, which will make it easier for you to focus on the information that you have without so many overlapping triangles. So we can see we have a side angle side case, which means we can use the law of cosines to find missing information. We won't be able to use the law of sines because we have only one angle, 100 degrees, and we do not know the side length opposite it. So we won't be able to make a ratio here. So let's go ahead and use law of cosines. We can use law of cosines to actually find what we want, which is the length of the resultant vector. So we're going to use law of cosines to find r, or the magnitude of r in this case, or the speed. So I'm going to set that up. So r squared is equal to 16 squared plus 260 squared. Fix my 16 so it looks a little better. 16 squared plus 260 squared minus 2 times 16 times 260 times cosine of 100 degrees And I put this in my calculator before, so I encourage you to do the same. This turned out to be r squared is 67,856 minus, this was negative 1444.75, and then r squared was equal to 69,300.7528, dot, dot, dot. And then when I took the square root of both sides, I found that r is equal to 263.25. So this is the speed. And now we need to figure out the angle. So if we go back to our triangle, the direction angle has to be back to the horizontal. So the direction angle is this angle here. Let's call that theta. Okay, so if we want to know that angle, what we can do is we can find this little angle, I'll call it x, inside our triangle. If we find little angle x, we'll be able to find theta, because x plus theta is 80 degrees. We know that from the first vector that we drew. Okay, so let's find little angle x inside our triangle. Now that we know that r is, I'll write this on here, 263.25, we can use law of sines to find x, the angle inside the triangle. So I'm going to have sine of x over the side length opposite it, which is 16, is equal to sine of 100 over the length, or the speed of the plane, the resultant speed, which was r, 263.25. So we'll multiply both sides by 16. So sine of x is equal to 16 sine 100 over 263.25. So that turns out to be 0.0598, dot, dot, dot. So x is going to be sine inverse of 0.0598. And if you enter that in the calculator, you'll find out that it is 3.43 degrees. That's this little angle inside the triangle, or here, 3.43 degrees. So the resultant angle for our plane's velocity is going to be, we'll call it theta, is going to be 80 degrees minus 3.43 degrees, which is 76.6 degrees. So to summarize, we can write the plane is traveling 263.3 miles per hour at 76.6 degrees.